Okay, so another example of a family tree where you can work out the genotypes of the parents and the children and work out the probability that their child will have cystic fibrosis. This is another example of that. So here we've got parents A and B. They are unaffected, but we know that they must be carriers. So in other words, they must be heterozygous. So, sorry, the battery went flat then. So they must be heterozygous, and we know that because, of course, they've had a child who has ended up with, well, they've had two children actually, both with cystic fibrosis. So this must be person A, this must be person B, and so therefore they've had these children, and there's been this chance of, there was actually 25% chance, but as it happens they've had two children, both with cystic fibrosis, which can happen. Remember, this is only a probability. So this person who is C, a female with cystic fibrosis, has had a child with this person here, and here are the children. And so what you'll be asked is, what's the probability of this child here having cystic fibrosis? Well, again, you need to go back to your Punnett squares, and what we can tell is that in fact this person must be a carrier, and he must be a carrier because if he wasn't, then the children would all be carriers of cystic fibrosis and not actually show it, whereas in fact this child shows it here. So therefore this person, so if this is person C, they've got cystic fibrosis, and so this person here, if we call him Y, for example, he must be a carrier. And therefore, when you work out the probability, there is actually 50% chance that that person here would have cystic fibrosis. So there's actually 50% chance, okay? And that's a typical question which you'll be asked. So always make sure that you look and be aware of the fact that cystic fibrosis is obviously recessive, and then Huntington's is obviously dominant.